Hello, everyone. This is a Transformative Vertical Flight Working Group on Public Services, meeting number 87. Today is Thursday, June 20th, 2024. We are excited to have a wonderful, impressive speaker, Ken Karklin. He's CEO of VTOL. I think pretty much everybody knows about VTOL. Really one of the pioneer in the industry, and very innovative concept, product and vehicle. And now you can hear some more interesting plan and ideas moving forward. Ken is going to talk about the pivotal today and the road ahead to public service missions, which is 100% in line with what we as a working group really focus on, how to leverage the technology, the industry advancement, and the capabilities, link up with the end user to serve multiple different public service missions, from medical transport, disaster response, humanitarian aid, and so on, fighting fire. I think California folks would appreciate that we might be able to do some good in a few years to leverage the capabilities to help fighting wildfire. Now, Ken is, as a CEO of Pivotal, he leads a company that's revolutionized the aviation industry with electric vertical takeoff and landing, eVTOL vehicle. Pivotal aircraft are light, efficient, personal area vehicle that transition elegantly from hover to cruise mode on mission in the recreation, public service, and defense vertical markets. Ken has 30 years of experience in engineering, operations, and business development in the semiconductor, aerospace, and energy industries. And you can see the additional his bio below. I went through the more detailed bio of Ken. I have to say it's very impressive. And having been the Senior VP and COO at AeroVironment, which is another company I very much admire, can really bring, in addition to all his other background and experiences, I think he can bring a lot to Pivotal. I'm looking forward to what Ken has to say. Now, before we get to Ken's talk, let me see if I can share with you just a few forthcoming meetings. One of them is the July 20th, 21st on the upper left-hand corner is the 18th Annual Electric Aircraft Symposium, which is co-located in Oshkosh, same place where we're going to have the EAA AirVenture Oshkosh 2024. That's a huge, huge meeting, a gathering. Just about anything, everything you can think of that flies is there. And of course, right after the Oshkosh, there is a AIAA Aviation Forum take place in Vegas in July 29th to August 2nd. That also including the Electric Aircraft Technology Symposium. I think many of you will be interested, and I will be on all three of those, so looking forward to see some of you there. On the upper right-hand corner, if you can see that, I put out a note there. There is a NASA AEWG, it's a AAM Ecosystem Working Group. There's several sub-working groups. This one is organized by the Aircraft Working Group. There's a meeting topic, bird strike avoidance, mitigation, and safety, which I think it's a very needed and important topic, and which will take place next week in June 27th. But I think you need to be a member, but you can sign in as a member to attend the meeting. Following that, there is a eVTOL Summit 2024 in August 19th and to 20th, taking place in Los Angeles, California. I'll be speaking in the morning session on the first day about the eVTOL for public services, opportunity and challenges. So hopefully we'll see some of you guys there too. Now, there is another important meeting coming up, which is the Commercial UAV Expo. I think many of you know that many of the eVTOL, especially in the prototype development stage, we leverage a lot of commercial heavy industry, industrial UAV technologies and systems and components. So that's a good conference, also happened in Vegas. September 17th, there is a 8th AAM infrastructure workshop. I think that's the other half of the equation. I think we all recognize how important that is. We can't just sometimes we need especially the urban air mobility environment, you really need the infrastructure in place for the industry to really have a significant growth. But also in other personal, recreational, business use, and so on. Even the public service missions, we may need temporary infrastructure available to support our mission. So that would be an important meeting, useful meeting. One more mentioning is the September 10th, 12th, 50th European Rotorcraft Forum going to take place in France. So anybody who's interested in visiting France during that time, that would be a good place to visit, to attend the forum. The 5th is anniversary meeting forum. I think it's going to be a good one. There's a lot of high caliber presentation discussions over there. So that's just some of the topics. If anyone who's aware of useful, meaningful, related conference meetings, please send me an email or drop me a note. I will make sure that we put out in the meeting discussion and reminder. Now, with that, I'm going to stop sharing my screen and let Ken take over.
Well, Johnny, thank you very much, and thank you for that very, very flattering introduction. I'll do my best to try to live up to it. I'm going to go ahead and go to a screen share here, and I'll switch applications here. We'll get going.
Okay.
Give me a thumbs up if you can see that okay?
Yep.
All right, well, fantastic. Well, thank you everybody for spending a little bit of time with us today. I've got probably about a 35-minute presentation here if I don't talk too much, and really would like to try to spend some time on any Q&A to the extent that there are any, and let everybody know where Pivotal is in its journey. So without further ado, this is a short sequence that we shot about a year ago. This is at the Huntington Beach Air Show of the Pacific. And this is one of the days where it was actually sunny and gorgeous. And here you get a feel for what this one-person air vehicle is really like, what the flight dynamics are like, how does it achieve vertical flight. You'll notice the distinctive tilting of the entire aircraft approach that the company's taken. But the company's been at this for a long time. I think really the company's in its 13th year. And it goes all the way back to our founder, a gentleman by the name of Marcus Lang, who after developing a process to manufacture memory foam at industrial scale, he kind of retired for a while. And that was when he was 36, and then he eventually decided to come back into industry, but looking at something completely different. And that is, he thought that battery density, carbon fiber structures, and power density in motors had reached a point where a personal air vehicle that mattered could be possible. So he built one on his farm in Ontario, and we believe became the first person to fly an eVTOL in October 2011. That got the attention of some important investors in Silicon Valley. The company moved to California, and they started years and years of iteration on this novel aero architecture. First, with this kind of truss or strut-based aircraft that you see, we call that our Generation 1. It was really just a platform to validate the propulsion that was underway. The company does build its own motors. And then a little further down the line, you'll start to see it evolve into something a little more aerodynamic, something that actually has room for an operator. You'll see Generation 2 and then Generation 3, and there were extensive flight testing done, almost all remotely piloted work, especially the extensive work that was done in Canada up in Tilsdale, where they actually really started to accumulate some runtime and validate the propulsion, the controls, and the controllability across the entire range of flight. Fast forward to 2021 was the first time that it actually appeared at Oshkosh, and we had a couple operators from Pivotal flying it for the big crowds there, and they were in the hover controller mode at that time for human flight, which gets you to a pitch of about 35 degrees, maybe 25 miles an hour forward flight. Fast forward to a year from there, it actually validated the entire range of operation in the black fly. We're flying in cruise flight, which is really where the aircraft gets more interesting and far more efficient. That's when it's pitched all the way forward. You're getting maximum lift from the wings. The motors actually tend to get really quiet. Wind noise actually tends to dominate the flight when you're in cruise. And in June 2023, 1 year later, we actually sold the first powered lift eVTOL and delivered it to a customer. And that put us ahead of, well, we think any entity worldwide. That was part of our early access program, which remains underway. And we are learning a lot from these operators. And we're also learning a lot from a small installed base we have with the Air Force. In October of last year, we announced what the production aircraft was going to be. It's called the Helix. It is a significantly updated aircraft, and we'll walk through what some of the differences are there. And in January, we actually opened up the portal for folks who actually wanted to put a little bit of money down and reserve a Helix. And we'll talk about what's happened this year. But before I go there, just reiterate our mission statement. You know, why do we exist? Well, we only exist to transform the world with the power of flight. And I think we're taking a very unique strategy to do that. We're not seeking to become a air taxi. We're going to focus on privately owned assets, at first in the ultralight space, ultimately satisfying missions in public service and defense. And with time and with interest and with a building installed base and a little bit of revenue, we'll be looking at larger air vehicles and different applications. So what's happened over really the course of the last 12 months? Again, in 23, we became the first entity anywhere to be shipping powered lift aircraft to paying customers. And by the end of the year, we completed that intake process for that early access program. We trained about a dozen pilots over the course of the year. Right at the end of the year, we crossed a line of 500 human piloted flights, 6.5K total test flights. And we announced the availability of the Helix. And in 2024, there's been more completed fulfillment of that EAP program. We've trained many, many more pilots, including non-owner pilots, journalists, subcontractors for the military, and of course, some of our own engineers as well. And we've also started training some friends and family of the Blackfly owners, so they can share the joy of flight with their family and friends. And that's about a 2-week training course. We'll talk a little bit more about what's involved there as we step through the whole safety focus that we have. We've delivered 8 aircraft to a Air Force subcontractor in locations in Texas and Ohio, and they are flying on their own today, literally today, in Ohio. And about a month and a half ago, we were awarded a direct-to-government OTA, that's Other Transaction Authority contract with the Air Force. This is really the company's first direct-to-government contract, and hopefully the first of many. But what this is giving us is access to restricted airspace. It's giving us access to wind tunnels, to training facility or testing facilities, environmental test labs, EMC, you name it. But we're really using it to focus on the rapid maturation of the Helix aircraft, which is the production follow-on to the Blackfly, which is really the developmental vehicle. And what else are we doing this year? Well, we're charting the course to how are we going to meet the needs of those high-value defense and public service segments. There are missions that are not relevant to us, but there are many missions that are relevant to us, even in the current state, with a aircraft that is actually fitting into the ultralight category. So what's really unique about Pivotal is our aero architecture. And this aero architecture is our platform. And it's supported by a set of proprietary electronics and software, triple modular redundant flight computers, a sensor suite. And what the Blackfly and the Helix and everything on our immediate roadmap have in common is that they use this aero architecture that we call tilt aircraft eVTOL. So in other words, we don't have rotating wings, we don't have rotating rotors. We actually rotate the entire aircraft using vector thrust to achieve cruise flight, which is our forward flight, and hover flight, and everything in between. And what I think is particularly important about how this architecture was implemented is that the operator, the pilot in command, has full command authority through that entire range of pitch, whether they're all the way down at full cruise flight or whether they're all the way up in hover. At 35 degrees, which is where we consider the changeover from one controller to the other to be, the only significant difference is that a left-right on the joystick goes from translating left and right in the hover controller to making coordinated turns using the control surfaces on the wings. Beyond that, it would almost be transparent to the operator. They do today with our current flight system have to make a conscious change from one controller to the other, and we're evaluating opportunities and control sets where it actually will be completely seamless. But the other significant advantage I think that we need to really emphasize in this aero architecture is simplicity. Without all those moving parts, there's a huge benefit in terms of weight, reliability, and cost. The downside is only, well, when you're in hover, it's a little bit like sitting in a dentist chair. And I can tell you that gets completely normalized with about an hour in the simulator. And it's actually the last thing you're thinking of when you actually perform your first flights. And what we get back from that is this massively reduced complexity. We have 12 control surfaces on this aircraft. 8 of them are RPM values. I think if you were to start counting on any number of other eVTOL architectures, you'll get into more than 3 dozen before you're done counting. So that simplicity offers significant cost, complexity, and reliability advantages. And that, in fact, is part of why we're actually in the market today, because there's just less to debug. Talking about the Helix, so the Helix is the production follow-on to the Blackfly, which is really the legacy developmental workhorse that the company's associated with for the past 13 years. It's gone through 3 major revisions and many, many minor revisions. The Helix has the same outer mold line, and that's very deliberate because we did not want to invest many, many months in coming up with a new control law for the vehicle. That said, it has different motors, different power bus architecture, different batteries, completely different batteries. The aerostructure itself, rather than being made from a hand layup wet composite that was done in-house, is actually based on a pre-preg carbon fiber composite system. Everything is very much focused on scalability, consistency, reliability, and robustness. It also gives us a little more oomph in the propulsion department, so we'll be able to take it up to at least 10,000 feet density altitude and fly with slightly larger payloads. What else comes with it are the kind of things that a private owner operator would expect to come with a small GA aircraft, but as options, as it does fit into the ultralight category. Most of these are not required, but many operators want them. Many of our operators are already, have pilot's licenses. So ADS-B, an emergency locator transmitter, and aviation radios or GSM radio, it's either or, are supported options for the aircraft. And the interior just feels a little bit nicer. It's a little more premium. If you've ever been or looked at the interior of a Blackfly, it is pretty stripped down and very much race car-like. That's the way I'd like to describe it. All right. Well, a little bit about, I think, what makes Pivotal different is in our market entry strategy. So again, we're focused on these light eVTOLs, not 4, 5, 6, 7 passenger air taxis. And we're entering the market at first through the Part 103 category. It is an all-flight vehicle. We've been through validations with the Light Aircraft Manufacturers Association to that effect, validating that it does fully comply with Part 103. And now that we're out in the market, have even dealt with probably competitors that have made a complaint to the FAA. So the FAA is also investigated that it does in fact comply with Part 103. Our goal is to have customers, safe, delighted customers who are out there experiencing flight and helping us build our installed base, get us into a little bit of serial production, get a little bit of revenue, and we're going to have the largest installed base of cloud-connected aircraft that we know of if we meet our projections over the course of the next 18 months. And we're going to learn a lot from that because, every time one of these aircraft fly, and usually the night after, it's going to push gigabytes of telemetry up to the cloud. That all lives in our data lake. We're running any number of algorithms on that accumulated data, and we're learning a lot. We're learning a lot about operator behavior. We're learning a lot about component performance under a range of environmental conditions. We're learning a lot about wear of battery cells over time. And that learning, we believe, is going to help fuel our competency to go take on bigger problems. None of this matters if it's not safe. And I think that, the Part 103 landscape is notoriously, kind of the Wild West when it comes to safety. It's gotten a lot better over the recent decades, but it was a kind of a rough neighborhood, particularly in the 80s and the 90s. The accident rates in that space were intolerably high, in my view. And, if we don't have safe customers, we don't have happy customers, we don't have a business. So we've taken safety incredibly seriously. We've invited a number of parties, both paid and unpaid, and government, to do deep dive non-advocate airworthiness evaluations. Now, this is not a certification process. It's not intended to replace the certification process. The fact of the matter is there is no certification process for an aircraft that looks like this. Closest thing to it would be light sport. And we all know that light sport's going to require a single reciprocating ICE engine. It's a design standard. Now, Mosaic, future state, that's where we're going to go to certify larger aircraft. But this is where we are today. One of the major ways we achieve safety is through fault-tolerant systems and self-diagnosing systems. So you can fly through a motor loss. In fact, if that motor loss is detected, the polar opposite motor shuts down, you're gyroscopically balanced, you're going to have a good day. We're constantly monitoring the health of the vehicle and can proactively reach out to a customer where we see, for example, you've got a servo that's pulling a little more current than we're comfortable with and would like to do a field. Simplified flight controls and a simple user interface are also critically important. The less complexity you can load your operators with to do basic operations, the better you're going to be biased to good outcomes. I haven't talked too much about training, but training is a huge piece of this for us. Our training is currently 10 days, whether you have a pilot certificate or not. And there we cover everything from, airmanship basics, little elements of Part 91, Part 103 compliance, a lot of time in the simulator to master the aircraft, because every flight you take is a solo. And then you graduate to actually performing flights either out at Byron Field or any number of other places where we've been doing test flights. And you'll perform at least 10 flights and successfully check off all the required skill areas before we send you home with your aircraft. And we have had operators where we've had to, about 2/3 of the way through the training, say, hey, this is probably not going to work out, and parted ways as friends and moved on with life. All right. And of course, this picture here, we're showing the aircraft with the parachute. I didn't talk too much about that. That is the safety measure of last resort, but it is also something we've characterized extensively. It's a full aircraft parachute. The operator stays exactly where they belong in the seat, and the parachute brings you back down to earth. It is the only system that is not actuated by the computer, at least as of now. It is separated from the computer as a manual actuation, and then the parachute controller informs the flight computers that it's entering the parachute descent flight state and shuts down all propulsion. Well, there's a lot of missions you could do with a platform like this, and it may not be exactly the aircraft we have that's fitting into the ultralight category. In the near term, it might be a variant that has a little more something, whether that's energy storage or propulsion or cargo capacity, or it's got additional instruments and sensors that are specific for certain missions. But where we're working with the innovation ecosystems within the defense industry is to find what are those high value missions that we think that we're uniquely suited to go perform. And it's actually been a pretty long list that have popped up. And one very, very important aspect of the simplified flight controls is the ability for piloting an aircraft like this to be an additional skill, not your full-time job. In the military, universally, if you're a pilot, you're a pilot. That is your military occupational specialty. The simplified flight controls and ease of use of a platform like the Helix actually creates an opportunity for DoD to look at this more like an additional skill, like being a parachutist, for example. They send you to airborne school for 3 weeks, and now you're a parachutist, you're qualified to jump out of aircraft as long as you're current. If you stop being current, you have to go get caught up on training, and then you're brought back into the system. It could follow a very similar model. It's minimally observable. It's very quiet. You fly at treetop levels and barely be noticed by folks on the ground when it's a cruise flight. And to date, we've done nothing to optimize those acoustics. There's a lot we could do. Again, most of our work with the platform in the last 10 plus years has been remotely piloted. Well, there's a lot of remotely piloted missions that exist that we could serve nicely. Tomorrow, well, what does it mean for tomorrow? We're going to focus on a larger airframe, at least double payload, likely about 1,000 to 1,200 pound or maybe even larger aircraft. Hybrid energy systems, so we can get more mission relevant range and endurance, and day-night capability to fly in a little bit of weather, which you certainly don't do with an ultralight. But perhaps most importantly above all is guidance, navigation, and control, being able to operate in RF degraded or denied airspace with no GPS. This is a big get for really just about anybody in DoD circles that we've had contact with because it's all about preparing for the next peer-on-peer fight. Counterinsurgency operations are behind us today. And again, those missions could be manned, optionally manned, or in many cases, a flight of N aircraft where you've got manned and unmanned teaming at work. All right, well, let's talk about some of the public service capability. And I'll spend a little bit more time speaking to where we're going to be going with this in the fairly near term. So what can we do, today or in the near term? Again, it's a 20-minute, 20-mile range, and that's with a significant reserve on the energy management side. Piloting is an adjustable skill, not your full-time job. So a firefighter, an EMT, they could be cross-trained to fly a vehicle such as this, and that becomes an additional skill that they maintain over time, much like perhaps driving the back seat of a ladder truck. Not something you necessarily walk out to the vehicle for the first time and just go do. It's going to take some training. It takes some maintenance of current skills. One huge advantage of electric aircraft is that, time to launch. If we're on a standby, we're maintaining fully charged batteries. Pre-flight has been done for the day, the very detailed mechanical checks that are done pre-flight. The time to launch could be under 2 minutes, because there is a short list of last-minute pre-flight checks that are always done under all conditions. And if everything is standing by, you can be off the ground, again, really quickly. And that's pretty unique to electric aviation. Don't think anybody sits in that position unless they're just literally running an engine and an APU all the time, which is not really sustainable. Where we could go with a larger airframe, it gets much more interesting. Again, 2 or more passengers, 450 pounds or more payload. And again, that would be a type certified vehicle. Probably first type certification would be under the forthcoming Mosaic construct. Assuming that roll making comes out anything like it went in, we'll be able to meet it, I think, robustly. And again, hybrid energy systems are also super interesting to us. But even an all-electric variant in that kind of size range would be capable of 60 minutes and 60 miles. So what are the missions? Well, the very first one where we're going to be satisfying, and this is not in years, but in months, is an air mobile EMT or paramedic. And this would be for a EMS response in a specific geography where we're set up to operate, where the 911 dispatcher knows, based upon the reposition of all assets, that the eVTOL with that EMT on board would be able to arrive before the ambulance would, meaningfully, by several minutes. And, minutes are chances of survival in the types of missions that we'll be supporting, which would be, number one, cardiac arrest victims, 2, trauma, crash victims, that kind of thing, where, the time it takes for that very first responder to be on site and render the right kind of aid is the difference between life and death. And as you go past, 10, 12 minutes, survival rates go down into the 20% range. At 5 minutes, they're in the 80% range, for example. This is going to be somewhere we're going to hope to be performing in the relative near term. Another big opportunity for an aircraft like this is really for municipalities, public service agencies to have at their disposal an air asset, whether it's going to be used for search and rescue in a pinch, or a missing child somewhere, or offshore response. And you might say, well, geez, there's a lot of missions here that sound like could be done unmanned, and you'd be right. But fire marshal doing initial response to a wildfire report really likes to get up in the air and see it with their own eyes before they're deploying their assets. And doing so can make that whole exercise a whole lot more responsive and productive for those firefighting assets, and hopefully achieve a good outcome sooner rather than later. And in the longer term, we've got an opportunity to develop a UAS-based firefighting capability. It's more of a swarm response where a wildfire is detected in a zone of operations via satellite, and a human supervised but not human initiated response is started with multiple such aircraft that are in the zone and can reach that point of ignition that's been satellite recognized and immediately deliver either water or other fire retardants. And there are other fire retardants that are much more potent on a per pound basis that could be used in such applications. Again, it lends itself to a larger response from a larger vehicle that's able to deliver more payload faster, faster flight times as well. But there's definitely a need there. There's definitely a significant business case. We're working with one forestry company, one of the largest forestry companies in South America. And I like South America because it's not FAA territory where we could develop this technology, and it's overwhelmingly unsettled, and there's nobody there where these things would be operating. Almost very few low population density. They're spending $50 million a year fighting wildfires. They have $200 million a year in crop losses. There's a business case there to be satisfied, because the rate, the amount of resources required to put down or contain a wildfire rose geometrically by the hour. So that initially almost unmanned, unhuman initiated response to get that good outcome sooner rather than later, even if that means you're accidentally putting out backfires or garbage fires in somebody's yard, is probably a good trade-off. But we're very early in that discussion, and there's still a lot more to be learned. Back to the air mobile or EMT paramedic CONOP. Again, this is something we're looking at doing with partners as early as probably about the middle of next year. So possibly a year from now, we will actually have a pilot operation. Pilot being, it's the first time it's operational. It's a prototypical. It's not done in many locations, but we're looking at 2 locations with a specific jurisdiction in Southern California, where you might be running EMT dispatch type operations. And I wish there was a whole lot more detail I could share here, but there are other parties involved in it, and not everybody has signed off on any sort of publicity. But the point is, it's a capability we have today. We could put an EMT in one of these aircraft, get them 10 miles downrange, pretty much faster than anybody trying to fight traffic. Certainly faster than anybody trying to traverse switchbacks and climb a big hill. And that's a capability that has the ability for us to be saving lives, to show the world eVTOLs in a very, very positive light. It's an application where the public tolerance for risk is going to be inherently higher. And it frankly makes it all much more believable to the public. And they start to think, well, that could be me. Well, that's an acceptable technology. Well, I could be someone who's flying that. Or I have no reason I shouldn't get on that air taxi. They're using this type of technology all the time. So we think it's super important for adoption. We think it's super important for public perception. But again, it has to be done well. It has to be safe. And it has to have good outcomes. So that's what we're going to be focused on, and why we're going to take a very much a slow crawl, walk, and we'll run much, much later. And I would say that we are actually doing simulation-based trials today at Pivotal, where we're running the tapes on past 911 calls and performing the exact flight that we would have had to perform to meet the needs of that 911 call. That's helping us put some criteria around which ones would be appropriate to take in parallel with that ambulance that's being dispatched on the ground every time, and which ones we'd probably want to sit out. Not every day is going to be flyable. And on those days that aren't flyable, well, within the zone of operations, that pilot and probably that tech that's supporting the operation will be out visiting places they might need to land. They'll be cataloging landing locations. They'll be updating the database. They'll be doing everything to reduce friction, so future calls, when they come in, go well. And with that, talk a little bit about the roadmap, and I'll walk through this very quickly, and then we'll, run through any Q&As. So this is the Helix. Capacity is 220 pounds for the operator. It's our 4th generation. We're going to be having manned and unmanned variants, and no, the cargo version won't have a door that looks exactly like that, and probably won't be carrying 55-gallon drums, but it is representative of the capability. One of the things we're looking at doing in the very near term is autonomous cargo delivery in denied environments. And as it turns out, 200 to 250 pounds is actually an underserved niche in the Department of Defense, even for 20-mile range. Talked a little bit about the potential firefighting capability notionally. Might look something like this, but 200 pounds of retardant only goes so far unless you're using some of the alternate materials that are a little more potent. And then finally, a flight of many aircraft. And this is kind of a manned-unmanned teaming example. You've got empty cargo aircraft, you've got one with an operator. That could be a flight of many, many aircraft. This is a scalable architecture. And what we've shown here is an example of scaling up something that's 348 pounds empty weight up to about 1,080 pounds empty weight, has the ability to carry 450 pounds of payload, or 2 people, or could be used as a medevac, optionally manned medevac, pilot self-rescue. And if we need to get to greater ranges and endurances, something more like 250 or 300 miles versus 60 miles, we could do that with a hybrid energy system and appropriately sized battery packs to support about 3 landing attempts. And this is what, for me, has made working at Pivotal just super exciting for the past 2 years. And that is all these happy pilots. Many of them with an aviation background. Some of them don't have an aviation background. But people are having a safe time. They're having a great time. They're enjoying the joy of flight. And there's nothing quite like doing it in an aircraft that, with 340 pounds empty weight, feels like an extension of your body. And with that, I'll do one little teaser, and then we'll go ahead and go to Q&A. Are you guys able to hear the audio here?
I am ready for the high. I am ready for the high.
All right. Well, I hope everybody's ready.
That's just amazing. Wonderful to see everything you have done and what you are going to do. Just music to my ears. What else can I say? Anybody has any questions for Ken?
So can I have something quickly, if that's okay?
Please
Sure.
go ahead.
So I think of this working group, I'm the only one that's been greatly inconvenienced by Pivotal so far. And we, as a joke, we were operating at Fort Hunter Liggett. I was trying to get a civil aircraft landing permit, and you guys were hogging the whole runway at Fort Hunter Liggett. So thanks for nothing. But it's really awesome to be operating there and see you guys. I've seen you guys at Oshkosh and seen you guys at Fort Hunter Liggett, and I'm extremely impressed. And one of the things that I really like of all the urban air mobility companies that I've worked with, the sort of unapologetic simplicity associated with the it's a single system. There's no tilt mechanism. There's no transition. It's a really clever way to solve a problem that a lot of people are struggling to do. So no particular question. Just want to commend you on where you've gone so far.
Thank you. Well, and we're always happy to work with you and deconflict if we're hogging a runway or something like that. We like to share.
Fair enough, but no, that was all in jest. We'll land next time when you're not there. But thank you.
Enough. Thank you.
Other questions?
A huge thank you to start with. Excuse me, John.
Go ahead.
A huge thank you to start with, Ken, especially on the public safety side of the house, where I spent a lot of years boots on the ground. And I pinged you on the messenger here and on LinkedIn, and would love to chat and invite myself out. I had a couple pieces of dialogue with Greg about some radio systems that I was hoping to get some support to, but I guess really the one question is there going to be a public show and tell or test flight or public event coming up soon? I missed the last one.
Yes, and I don't have those details at the tip of my finger, but Martha or Greg, if you wanted to pipe in, let us know.
Yeah, and I'd love to see it in action and support the cause. So
thank you. Thank you, Kurt.
Hey, Ken, just to add on, Kurt is one of our resident working group public service expert. He got a lot of background experiences. It's I learned a lot from Kurt, and I think it's definitely worthwhile dialogues.
Well, we'd love to have you out, Kirk. Let's make sure we connect. And apologies if I've not been responsive enough, but our doors are open to you in Palo Alto.
Oh, thank you very much. Nothing like that. We're all just busy, Greg and I. Yeah, it's all been good. Just everybody's juggling things, but I'd love to come out soon. I'll ping Martha my contact as well. Cheers.
Awesome. Thank you.
Other questions, thoughts?
Hey, Ken, can you put your email address in the chat so we can reach out to you?
I could try. I'm on an iPad.
Oh, okay.
So I'm a little.
Maybe Johnny can do it later.
Johnny, if you would mind doing that for me.
Well, I can't do that right now.
Yeah,
technology
or
challenge.
Martha. Yeah. So
But for sure, I will definitely, if Ken don't mind, for sure, I'm sure I will get you his email. Yeah, and by the way, Ken, Al is basically runs the flight test working group. What do you call it? Don't call it working group, right? You call it
eVTOL Flight Test Council.
Yeah, there you go.
We do best practices on flight test of all these aircraft.
So another valuable person.
We definitely have some people who would like to be talking to you. Yes. Great.
That brings up a question, Ken. I'm spending a fellowship at the Air Force Test Pilot School, and so speaking of flight test, they do qual eval. They're going through a host of the test pilot and the flight test engineer students. They go through a whole bunch of different aircraft, 28 aircraft or so. And I know you're already working with Air Force, but it would be good to eventually have you roped in so you could put one of these on site at Edwards and have students go through possibly an abbreviated session, unless you've already considered that. But happy to make that.
Oh no, that's a great input, and it is something I thought about. Actually, I thought about it before I started because I happen to have a pretty good relationship with I think he's still the commander of the Naval Test Pilot School, who's actually an Army guy, Colonel Aaron Kia. And they do this capstone program, all the test pilot students, where they have to go evaluate an aircraft that is foreign, at least to them. And usually it does wind up being an actual foreign aircraft or helicopter or what have you. But there's an opportunity here. And I look at that as more non-advocate review. And I'm a big fan of non-advocate review because we always get something out of it.
Yeah. So I'll email you some information, but it's something that in the future, if it's possible to make that connection. I mean, obviously TPS pays for the aircraft, but this is one where the TPS curriculum is trying to be modernized. And as you were saying, that how do you adapt your flight test protocols to aircraft that are not a T-38 or F-16?
Right.
It'd be very interesting to have this one as part of the curriculum.
And we're going to be very focused to get through the initial launch of the Helix in the near term, which really modernizes and gets that architecture into a place where we think it'll be highly supportable. We want to have more of that not every review. We've had some with, Air Force, Dayton Aero, Aerotech, others already. We want more.
Yeah, Ken, I'm particularly interested in well, all the missions that you talked about, but the fighting wildfire, that was particularly I think is meaningful and could be near-term use cases. I know NASA is pretty interested in focusing on the fighting wildfire, on leveraging the eVTOL technologies and so on. So they're working on the data system, the imagery, and eVTOL can be easily part of that whole overall equation.
Absolutely.
Yeah.
Sorry, go ahead.
Oh, no, go ahead.
Well, I was going to say, of all the missions that I outlined, at least at a high level, that is the one that actually has the most, I'll call it invention on the critical path. Whereas virtually everything else we described, I think, is a matter of integration of existing and proven technologies.
Yeah, it's I like the wingman approach. Also, I mean, I talked to some fire chief. I said, "Do you want to fly in eVTOL on the fire zone?" He said, "Yes." I said, "Why would you need that? You got a whole bunch of drones flying around." He said, "No, I want to be up there in person. I want to see it. I can make better judgment in person than I can without with all the drone images." So I think that wingman approach, the mother duck leading a whole bunch of little ducklings, will be probably a implementable near-term solution that can really make a difference. I mean, you're right that each airplane doesn't carry in a lot of, not like a water bomber on the capacity, but if we can, what I call the distribute on-demand response, that the airplane or several airplanes can converge on a new start fires. We can at least contain it or slow it down, or we can put it off, and that can make a huge difference. So we might be able to avoid 1 or 2 or even 3 major outbreaks on fires. So imagine the results, the benefits, or even life savings. That's huge.
Well, I think it's only with that kind of distributed resources approach that you could effectively mount a counterattack against downwind spot fires that are constantly popping up like popcorn 2 miles downwind of the main line. And it's that's the thing that we've seen anyway.
Good deal. Anyone else has any questions or comments?
Very impressive. Thank you, Ken. When are you coming to the Middle East? I'm tired of seeing non-American aircraft flying here. I want an American aircraft. Aircraft here.
We're not taking a super aggressive stance in our export strategy, but Middle East is absolutely shortlist, so it will hopefully be sooner rather than later, because I think that the acceptance that we're seeing and the interest is much higher. So love to talk offline.
Awesome. You're invited to DreamHack 2025. That's going to be in March of next year. This year you couldn't make it, but next, and Sun and Fun 1st April too. We'll talk offline. Thank you.
Sounds good. Well, I really want to thank everybody for being so supportive and receptive and taking the time to allow Pivotal to share our update with you.
Yeah, super excited. Yeah, I have to thank everybody for attending, and thanks Ken and Martha to make this happen. Really excited possibility, and glad to see all the progress you guys made. With that, it's at the time of our session. I thank everyone, and I'll see you guys next time. And if anybody wants to get in touch with Ken, please let me know. I'm sure Ken will be more than happy to, and Martha will be more than happy to connect with you guys. See you guys next time.
Thank you again.
Thank you very much, everybody.
Thank you.